Good morning, everybody. In this webinar, I'm going to explain about the technology used in the wind turbines and wind energy project requirements. Overview of wind power industry: wind site selection, turbine selection, turbine design, project management, logistic management, erection management, and commissioning. After commissioning, monitoring the turbines, certification, wind turbine certifications, case study, and job opportunities. Wind site selection. Wind site selection, first we have to analyze the transmission line. Transmission line, whether for the particular wind site, transmission line available or not, and connecting roads, and is there is any restrictions. If transmission line not available in that site, we have to lay a transmission line. We have to see how much distance and cost, and connecting road available or not to transport the heavy components. But analyze the restrictions. If there is any restriction for the particular land, it is a military area, it is a forest area, residential area, there is any nearby any airport. These points we have to first analyze before choosing the wind site. After choosing the wind site, we need to go for a resource, whether wind potential. There is a team in every wind industry. They will have a wind resource team. Better resources, greater the potential power. So we want to identify a better resource to get the maximum power from that particular site. We have to analyze the wind data, particular site wind data, and what is the potential, wind potential. Most of the cases, maybe in some cases, after analyzing and installing the turbine, the generation, it will not, it will affect the generation. To avoid this wind site selection and wind resource, analyzing the wind potential is important. So what we have to do? We have to install a wind mast. In the particular available area, we have to install a wind mast. Wind mast is a steel structure. Steel structure, height about 100 to 120 meters. For installing the wind mast, where to install the wind mast and how to collect the data and all these things, standards are available. International Electrotechnical Commissioning, IEC, they are releasing the standards for wind mast and also for the wind turbines. In the wind mast, we have to install the anemometer. Anemometer is for measuring the wind speed. What is the wind speed at the particular site? And wind vane, which direction the wind is in the which direction. And the temperature sensor. What is the temperature sensor for minimum of 1 year? And solar radiation. And what is the vertical wind speed? And barometric pressure, relative humidity. These parameters we have to measure in the particular site. And after measuring these data, in the wind mast itself, they will provide a data logger. Data logger to store the device with the storage device, and data transferring, online data transferring for internet facility available. So the temperature sensor, anemometer, wind vane, solar radiation, vertical wind speed, barometric pressure, and relative humidity. These details we have to collect from the particular wind site. After collecting these data, we have to analyze what is the wind class. As I told earlier, IEC, International Electrotechnical Commissioning, they are releasing the standard. They have specified what are all the wind classes available throughout the globe. If wind speed more than 10 meters per second, that means it is a high wind class. That is called IEC 1. If the wind speed above 8.5, that is called IEC 2, that is a medium wind. If the wind speed 7.5 meters per second, that is called low wind. Normally, not only that, actually, also we have to measure the gust wind also. Gust wind and also the turbulence level. These three parameters will decide the wind class. So we got the land. Now we put the mast and analyze the wind class based on the wind class, we have to select the turbine. Turbine selection is based on what type of wind class, available wind class. So normally, while designing the wind turbine itself, the designer will specify what is the wind rotor diameter, what is the rated power, and what they are offering to the customer tower height. Suppose if you are analyzing and identify the wind class is 2, then the turbulence level is B, turbulence percentage level is B, means that they will mention as in the product itself. This turbine is suitable for wind class 2B. So based on the designer recommendation, manufacturer recommendation, you have to choose the turbine. In the turbine, the specification itself, they will mention what is the rotor diameter and what is the rated power of the turbine and the tower height. Tower height, normally it will vary. For the same rotor diameter and rated power, manufacturer, they will offer for various heights. So based on these three specifications, you have to choose the turbine. Here, this is the blade diameter is normally called the rotor diameter, swept area, and the tower of center of the hub height, it is called the hub height. That is the height of the wind turbine. And also rated power, it is for the generally for the generator. Generator is the rated power. Based on these conditions, you have to choose the turbine. After choosing the turbine, we have to we cannot install turbine anywhere, because there are the front turbine will produce more power than the turbine behind the wind power that will produce less wind power. So to avoid this, there is a procedure for micro setting. Micro setting softwares are available. Various softwares available now. So in the micro setting, what we have to do, we have to go for a wind direction. What they will do, what are the wind direction for the particular site? Normally, wind direction will change to wind direction will change. So for that, what is the first wind direction, and then what is the air density for the particular site, and also if there is any icing formation and icing frequency. And normally it is based on the terrain. That means the level of the area. But is the plain area means that spacing the wind farm is different. If it is a hilly terrain, or if it is near to the coast, or it is onshore, offshore, based on this, the turbine distance may vary. So what they will throughout the year, they will place a different wind direction. What is the number of turbines and the distance, annual energy generation. What they will do, they will calculate the annual energy generation for the particular wind site. This number of turbines is possible. This is the annual energy generation for the particular site. This is arrived through the software and also for the manual calculation also. But normally softwares are available. Software, they will give you the, not only that, actually, it will give you a turbulence also, not only the natural turbulence. Because of two turbines effect, it will create a turbulence. That also we can predict. And then based on this distance of the turbines, they will place. And normally, how to calculate the annual energy generation? While manufacturer itself, they will specify the manufacturer itself, they will specify the theoretical power curve. Theoretical power curve with turbine data, they will give you the theoretical power curve. This is the theoretical power curve. This is for the 800 kilowatt turbine. This is the 800 kilowatt is the maximum generation. And normally 10 to 12 meter per second is enough. Not only for 800 kilowatt, even for 1 megawatt, 1.5 megawatt, all these turbine, maximum wind speed is required is 10 to 12, maximum of 14. That's all. So this one, in 2.5 to 2.8 meter per second, the turbine will start. It depends upon the manufacturer. So some turbines will start at 3.5 meter per second. Some turbine will start at 4 meter per second. So 2.8 normally some maximum turbine 2.83 meters 2.8, that is called cut-in. The blade will start and then start cutting the wind, and that is called cut-in. Cut-in wind speed is 2.8 or 3 meter per second. If it is reached to 10 to 11 meter per second, it will reach the maximum power generation. Above that, if there is any high wind or anything, it is not useful for the turbine. There are surveillance. While designing itself, they will mention the surveillance wind speed up to 25 meter per second. Some manufacturer will give 30, 35 like that. The turbine automatically stop because due to overload, it will not withstand. It is based on the design again. So the turbine will automatically stop. So based on this power theoretical power curve, before starting the wind farm itself, they will calculate what is the annual energy generation produced for the particular site. And after choosing the site and after calculating the annual energy generation, we have to go for which type of turbine we require. Whether we require, there are various types of turbines available. Upwind turbine, downwind turbine. Turbine depends upon number of blade, stall regulated turbines, and also pitch regulated turbines, turbine with gearbox, and turbine without gearbox. These are all the various type of turbine available. This is the difference between the downwind turbine and upwind turbine. Downwind turbine are the same direction of the wind. This is a older technology. There is a it is not possible to various wind direction. It will be in the same direction only. This is an older technology. There is no bearing below the nacelle, so that it will stand in the same direction only. But latest one is upwind. Upwind is the latest technology. There is in various wind direction also, it will turn to the wind direction and it will generate to various wind direction speed. The latest technology is the upwind. Upwind is the better one compared to the low wind. If the wind site is having only particular direction only, it is not, there is no second wind direction means, then we can choose for downwind turbine also. There are stall regulated turbine. Stall regulated turbine, this is also older technology. Actually, the blade of the turbine fixed to some angle. There is no provision given to the blade to rotate. So the variable speed is not possible. So in this, you can see the rotational direction and yaw angle, and also the blade permanently fixed to particular direction. Up to 250 kilowatt smaller turbine will have a stall regulated turbine. These are all the old technology turbine. Safety and all these things, controlling the turbine, all these things are a bit critical in this type of stall regulated turbine. You require additional brakes and all these things. So this is the stall regulated turbine with fixed blades. This is the pitch regulated turbine. Pitch regulated turbine is the latest technology. Actually, they will provide the bearing at the end of the blade. They will provide the bearing. The individual pitch blade rotation is possible. They will offer you, depends upon the manufacturer, 360-degree rotation for some manufacturer they will provide. And there are various technology also available, internally geared, belt driven, various technology available. So pitch driven is a latest technology. The advantage of pitch driven is you can start the turbine in a minimum 2.83 meter per second is possible. And the main advantage of pitch regulated wind turbine is the blade will act as a brake. The safety is high. So in case you want to stop the turbine, it is against the wind and then wind itself, it will stop the turbine. So the latest technology as per IEC norms, this pitch regulated are preferred. If you go for a certification, pitch regulated are preferred to go for a latest technology. And the safety is very high in this one. So in the wind, actually I explained the anemometer and wind turbine. On all the anemometer and wind turbines, these are all the common anemometers. Cup anemometer. This is a cup anemometer. It will rotate for wind direction, and it will sense based on the rotation of the wind. It will sense and it will communicate to the hub to rotate the blade. This is the cup anemometer. In some cases, it is difficult to use the cup anemometer because icing formation, weather condition. So in that case, ultrasonic anemometer is the latest one. Accurately, it will sense the wind direction, and even the very low wind also it will sense, and it will communicate to the turbine. So these two are anemometers to measure the wind speed. So this is a conventional type of wind turbine. Actually, the gearbox available. The blade normally connected to the main shaft. This is called main shaft. Actually, the in between connecting the main shaft and the blade, this is called hub. Hub is a casting part. The blade, the main shaft, is connected to the secondary shaft here. The shaft is connected to the generator. This is the conventional type. Normally, right from the beginning, this is the model. It depends upon the capacity. Depends upon the capacity, the gearbox, generator, and blade hump, it will vary. So this is the conventional one. Anemometer will give the signal to the system. Then only the blade and hub, it will rotate. While hub rotating, the main shaft will rotate. Main shaft rotating, it will connect it to the pinion rotate to the generator. This is the normal technology available right from the beginning. Now this is the cross section, the blade and gearbox connected to the generator. There's a control panel, and there is a rotation for the wind direction. Two terminologies are important. One is individual blade rotation, pitching, I explained. And another one is yawing. Yawing means the complete machine based on the wind direction. The wind direction change, it will the signal, that is a wind vane give the signal to the gearbox and the control system. The entire turbine will rotate and for the wind direction. This is for the cross section. Normally, they will provide the brakes for the safety, and there is a one gearbox available. This is a yaw gearbox. Is a main gearbox, pitch gearbox, yaw gearbox. 3 gearboxes available. This is the conventional wind turbine. Now there are improvements in the wind turbine. This is the direct drive. The difference between conventional and direct drive, there is no gearbox in this direct drive. Only gearbox available for the conventional drive. Here there is no gearbox. Hub and the blade directly connected to the shaft, and it is a low RPM also. Throughout, complete turbine will rotate in a same RPM. 18 to 20 RPM is the normal rotating speed for the wind turbine. The rotor, the rotating part connected to the coil or the magnet internally with the generator rotor, and the static part that is connected to the coil. The difference between conventional and direct drive, here there is no gearbox, but for the direct drive, you have to use a converter. Mechanical components are more in conventional type, but direct drive, mechanical component less, RPM also less, but electrical component, because of a converter, electrical components are more. And braking system, everything, and controlling the turbine and everything is possible in both conventional and direct. This is the yaw system. I explained the pitching system. Yaw system, they will provide the bearing here. Bearing, they connected to the internal gear and the gearbox. Based on the wind direction, it is called wind vane, will give you the signal to the yaw system. Yaw system, based on the wind direction, it will rotate. And this is the axis. This is called the complete assembly is called nacelle. Nacelle, it will contain the generator, gearbox, and the yaw system in between the tower and the yaw frame. This is the normal yaw system functioning. Then we will go for turbine design. Turbine design, we have seen the land, based on the land, how to choose the turbine, and after selecting the turbine, which type of turbine we have to choose, types of turbine. Now it is for the turbine design, how to do the design. Design, actually, there is a difference between other manufacturing methods and this manufacturing method. Normally, other manufacturing method means thermal, hydro, even nuclear. all these other systems, input control and input is possible. But here in the wind, input, stoppage of input and control is not possible. If you take thermal, you can put a valve and then you can regulate and rotate the speed, rotate the turbine in a regular speed. And if you want to stop the turbine, you can close the valve and you can stop the turbine. In case of hydro, you are having a butterfly valve to regulate and to stop the input fluid. But here in wind, input control is not possible. All the safety measures and also control everything the designer has to consider in the design itself. Rotating design, main concept of design for wind turbine, rotating the wind turbine is not a difficult one. Technology is simple. Rotating the turbine, control and stoppage of turbine is a technology, is the complicated in the wind turbines. Normally turbine, overspeeding the turbine control, these things are critical in the wind turbine design. So if you want to become a designer, you have to keep in your mind, controlling and the wind turbine is the major task. Turbine design, how to design the turbine. Due to various reasons, the normal turbine available for the normal areas. Also, onshore turbine available, offshore turbine available. Normally, the normal turbine, also the ambient air quality, you have to consider the seismic, what is the seismic in that area, and near site requirements. Normally, the turbine designed for 0 to 40 degrees centigrade. This is the normal turbine design. In case you required for -20 degree,